Okay, I think we should start. Is my screen visible?
Yes, sir.
Okay,
Yes, sir.
all right. So let us quickly recall what we did in last lecture. So we are studying partial differentiation, in which we came up to the concept of total derivative or total differential. If f of xy is function of two variable, then its total derivative is given by df, and which is defined as da by f by da by x dx plus da by f by da by y dy. Okay. Then we note that if z is function of xy and xy are functions of one variable t, then we can talk about ordinary derivative of z with respect to t, that is dz by dt equal to da by f by da by x into dx by dt plus da by f by da by y into dy by dt. Similarly, it is true for three variable case. Okay, so u is function of xyz and xyz are functions of t. Then you can find out du by dt, which is given by w by w x dx by dt plus w by w y dy by dt plus w by w z dz by dt. Okay, and then one problem we considered yesterday, u is function of xy, that is x square plus y square, and x and y are functions of t. So x is 80 square and y is 280. Then question was to find du by dt. So u is function of xy and xy are functions of t. So by chain rule, du by dt is equal to w by w x into dx by dt plus w by w y into dy by dt. So we find out this derivative explicitly and then substitute values of x and y, so that you will get answer in terms of t. Okay, so any doubts so far?
No, sir.
No, sir.
No, sir.
Fine. So let us go to this problem again. This is very easy because it's only about derivatives. So if u is equal to sine of x upon y, and x is e raised to t, y is t square, then question is verify du by dt equal to w by w x into dx by dt plus w by w y dy by dt. That means verify chain rule. That's the question. Now verification means you find out du by dt. That means you find out LHS and then you find out RHS. You multiply these derivatives and check whether it is same as the derivative at left hand side, that is du by dt. Okay, so let us find out du by dt first of all. So you need to substitute x and y as function of t. Okay, so u is equal to sine of e raised to t upon t square. This is my u in terms of t. So du by dt is cos of e raised to t upon t square into derivative of e raised to t upon t square. Again, you need to apply quotient rule for that. So t square into derivative of e raised to t is e raised to t minus e raised to t as it is, the derivative of t square is 2t upon t raised to 4. Okay. So cos of e raised to t upon t square, if you simplify this, you will get 1 by t square, 1 t square will get cancelled, minus 2 by t cube, outside bracket e raised to t as it is. Okay. So this is left hand side. Now you have to find out these derivatives on right hand side and multiply them and add them. Okay. So u is function of xy are functions of t. So by composite rule, du by dt is w by x into dx by dt plus w by y into dy by dt. So w by x is cos of x by y into derivative of x by y with respect to x, which is 1 by y, into dx by dt, that is e raised to t, plus w by y is cos of x by y into derivative of x by y with respect to y, which is minus x upon y square into derivative of dy by dt, that is to t. Okay. Now cos of xy you can take out, 1 by y e raised to t minus 2x upon y square into t. Okay. Now substitute values of x and y so that you will get everything in terms of t. So cos of e raised to t upon t square, x is e raised to t and y is t square, 1 upon y, so 1 by t square into e raised to t, minus 2 into x, x is e raised to t, so 2 e raised to t upon y square, so t raised to 4 into t. And if you simplify this, you will get same thing as you got this du by dt. Okay, that's the verification. Clear?
Yes, sir.
Yes. Okay. What about others? Is this fine?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Are you copying this? Or we can go ahead. Please respond.
1 minute, sir. 1 minute.
Okay. Done?
Yes, sir.
Yes, sir.
So let us go ahead with a new concept and a new notation, that is variable to be treated as a constant, which is denoted by suffix. Okay. So please understand that this slide talks about only notation. So these are particular examples. Okay. So if x is equal to r cos theta and y is equal to r sin theta, then we can observe that x square plus y square is r square, because cos square theta plus sin square theta becomes 1. So if you introduce notation, da bar by da bar x suffix theta means partial derivative of r with respect to theta, provided there is a relation expressing r as a function of x and theta. Okay, provided there is a relation between r, x and theta. Okay, I repeat, da bar by da bar x suffix theta means partial derivative of r with respect to x, treating theta constant, provided there is a relation between r, x and theta. So can you tell me da bar by da bar x suffix theta? Yes, from
Sec
above,
theta.
sec theta. Okay, good. Because you can write this r as x by cos theta. Okay, so x by cos theta is nothing but x sec theta. Now r is equal to x into sec theta. Differentiate it with respect to x, so that becomes sec theta. Okay,
Yes,
so
sir.
right,
Sir,
yeah,
I couldn't understand it properly because in between the voice broke.
okay, okay. I'll repeat. So if you have two relations x and y, okay, or any variable s and t, okay. So partial derivative of say r with respect to x suffix theta means derivative of r with respect to x treating theta constant, provided there is direct or indirect relation between r, x and theta. Okay, so if I ask you what is daba r by daba x suffix y, okay, suppose I have given you x is equal to r cos theta and y is equal to r sin theta, and I ask you to find out daba r by daba x suffix y, means what? Find derivative of r with respect to x treating y constant. That means I need to find out relation between r, x and y first of all, and then I differentiate it with respect to x treating y constant. So tell me da bar by da bar x treating y constant.
2x.
Cos theta,
Cos theta, which is nothing but x by r. Okay, so let us understand it. So what I have is r square equal to x square plus y square. I want da bar by da bar x. So differentiate both sides with respect to x, treating y constant. So derivative of this r square is 2r into da bar by da bar x is equal to 2x, and derivative of y square is 0 because y is constant. So da bar by da bar x is equal to x by r, and x by r is nothing but cos theta. All right. So
Sir, 1 minute. Can I write this down?
yeah, yeah. Please write it down. Everybody, please note this down. Done?
Yes, sir.
Okay. So let us go to the problems of suffixes treated to be constant. So two relations are given. U is equal to ax plus by, v is equal to bx minus ay. Now various problems can be formed using this by giving particular values to a and b. Okay, there are number of problems which can be formed from this equations. And you have asked to find out dabba u by dabba x suffix y, dabba x by dabba u suffix v, dabba y by dabba v suffix x, dabba v by dabba y suffix u. Okay. So let us go to step by step. So we need four partial derivative and their multiplication. So what is first? U with respect to x treating y constant. So to find out this derivative, do we have relation between u, x and y? Do we have relation between u, x and
Yes,
y?
sir.
Yeah. The first equation is relation between u, x and y. So you can directly differentiate. So dabba u by dabba x is a. Okay. So first derivative is fine.
Yes, sir.
Okay.
Yes, sir.
Let us go to this second derivative. Dabba x by dabba u suffix v. So we need to check whether we have relation between x, u and v. Direct or indirect relation. So do we have relation between x, u and v? That means what? You need to eliminate y, isn't it? Are you getting?
Yes, sir.
So to find out dabba x by dabba u suffix v, you need to have relation between x, u and v. So you need to eliminate y from this 2. Okay. So this is what is given to you. Y is equal to u minus x upon b. From first, y is equal to u minus x upon b, which is also same as bx minus v upon a. Okay, bx minus v upon a. So if you simplify this, if you cross multiply this, you will get au minus a square x, then b square x minus bv. Okay, so from this you will get x as, if you take this a square x to this side, you will get au plus bv upon a square plus b square. So this is x. So you have eliminated y from these two equations. Is this equation clear to everyone? X is equal to au plus bv upon a square plus b square.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay. Now you differentiate it with respect to u treating v constant. So dabba x by dabba u suffix v is equal to a upon a square plus b square, and this second part ka derivative is 0. Okay. So equation 3 is fine.
Yes, sir.
Yes, sir.
Okay.
Yes.
So third partial derivative is dabba y by dabba v suffix x. That means we need to have relation between y, v and x. Do we have y, v and
Yes,
x,
sir.
right?
Yes.
What is that?
Second equation.
Second
Second
equation.
equation.
Yeah, good. Second equation is the relation between y, v and x. So what is dabba y by dabba v? Tell me. Tell me dabba y by dabba v, treating x constant.
Minus 1 by a because the first term becomes 0.
Yeah, good. It is minus 1 by a. Okay, you can see it here. This second step or equation 2 is dabba y by dabba v, which is equal to minus 1 by. If you differentiate this with respect to v, this is 1 equal to 0 minus a times dabba y by dabba v. So that becomes minus 1 by. Fine? Yes?
Yes, sir.
Okay, fine. So lastly, partial derivative of v with respect to y treating u constant. So we need to check whether we have relation between v, y and u. Of course, there is no direct relation between v, y and u. So let us eliminate x from both this equation. Eliminate x from these two equations. So u minus by from first u minus by upon a, which is equal to v plus ay upon b. Both are same as x. Okay. Now if you cross multiply, you will get bu minus b square y equal to av plus a square y. Okay. So v you can find out from this. So v is equal to bu minus of a square plus b square into I upon a. Okay, now you differentiate it with respect to y. So derivative of this first part is 0. So dabba v by dabba y treating u constant is equal to minus a square plus b square upon a. Is this fourth equation clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now just substitute these values. Dabba v by dabba x suffix y is a, x with respect to u treating v constant is a upon a square plus b square. Then dabba y by dabba v suffix x is minus 1 by a, and dabba v by dabba y treating u constant is minus of a square plus b square upon a. So everything gets cancelled and you have answer as 1. Okay. See, mass distribution is very simple. If this question is asked for 5 marks, then 4 partial derivatives carries 4 marks, and final mark is for this calculation, okay, or the final answer. All right. Any doubt in this?
1 minute,
No,
sir.
sir.
Sir, I have to write.
No, sir.
Yeah, okay. Please write it fast. Done? Yes, please respond. Have you copied? Someone was copying.
1 minute, sir. 1 minute.
Okay.
Done, sir.
Okay. So second problem of that kind is u into x plus v into y is equal to 0 and u by x plus v by y equal to 1. Then we need to prove that u by x into da by x by da by u suffix v plus v by y da by y by da by v suffix u equal to 0. Okay. So you need to find out these two derivatives and you are through. Okay. So we have from first we have y is equal to minus ux upon v. Okay. Uh, then u by x plus v into 1 by y, which is minus v upon u into x. Now, if you simplify this, you will get u square minus v square upon u into x equal to 1. Okay. U square minus v square upon u into x equal to 1. So from which x is equal to u square minus v square upon u. Okay. Is this relation clear?
Yes, sir.
Okay. Others?
Yes,
Is
sir.
this fine? Yeah. So differentiate x with respect to u treating v constant. Okay. So it is u square upon u, which is u, the derivative is 1, minus 1 by u ka derivative is minus 1 by u square. So minus minus become plus. So 1 plus v square plus 1 plus v square upon u square is the derivative of x with respect to u treating v constant. Fine.
Yes, sir.
Yes, sir.
Now second, y with respect to v treating u constant. So you need to find y, v and u ka relation, that is eliminate x. Okay. So x is equal to minus vy upon u. So x is equal to, from this first, x is equal to minus vy upon u. So you substitute this value of x in this second expression. Okay. Here. So u into 1 by x. So you substitute value of x so that that will get eliminated. So u into minus of u upon vy plus v upon y equal to 1. Now if you simplify this, you will get y as v square minus u square upon v. Okay. And now you differentiate y with respect to v treating u constant. So which is 1 plus u square upon v square. So take LHS now. U by x into da by x by da by u suffix v plus v by y, da by y by da by v. Okay, equal to, substitute these values. So u by x, da by x by da by u is 1 plus v square upon u square, and you multiply by u by x to it. So u by x plus v square upon xu plus v by y into this da by y by da by v. So it becomes v by y plus u square upon uh, y into v. Okay. So u square plus v square, if you multiply this by u, so it becomes u square plus v square upon xu, and if you multiply by v to this, multiply and divide, then you will get u square plus v square upon yv. Okay, so u square plus v square you can take out, you will have yv plus xu upon xu into yv, but this is 0, xu plus vy equal to 0, therefore this whole thing is 0. Any doubt in any step? Yes.
No, sir.
Others, please respond. Do you have any doubt in any of the step?
No, sir.
No, sir. No, sir.
Okay. Do you want to copy this?
Yes, sir. 1 minute.
Okay. Do you want me to scroll up for previous slide?
No, sir.
Yes, sir.
Okay. Write it fast.
Sir, next slide.
Okay. Yes.
Yes, sir.
Yes, sir.
Okay. So practice those problems from question bank which I have already shared, and in case of any doubt, you can post it. Next is differentiation of implicit function. So I hope everybody know what is implicit function. A
Yes,
function which cannot be expressed as or in terms of one variable. Okay, so the function which is not explicit is called as implicit. So let f of xy equal to 0 represent an implicit relation which cannot be necessarily be solved for one variable, say x, or you can say y in terms of other variable. All right. So for example, x cube plus y cube equal to 3axy, or x cube plus y cube minus 3axy equal to 0. This is implicit function. Okay, where you can't express y in terms of x and or x in terms of y. So how to find partial derivative of such function? So let us write it as z. Okay, write down that function as z. So z is equal to f of xy, which is equal to 0. Okay, now you differentiate it using concept of total derivative. So dz equal to daba z by daba x dx plus daba z by daba y dy. Okay, which is again same as dz by dx equal to daba z by daba x dx by dx plus daba z by daba y dy by dx. So this dx by dx becomes 1. So dy by dx you can calculate, which is daba z by daba x minus upon daba z by daba y. Okay, from this you can calculate dy by dx as daba z by daba x upon daba z by daba y, and which has minus sign, which is also same as daba f by daba x, and this daba z by daba y is also same as daba f by daba y, and it has minus sign. Is this fine? Dy by dx. Understood?
Yes, sir.
Okay. Others?
Yes, sir.
Yes, sir.
Fine. So if you introduce few notations, P as daba f by daba x, Q as daba f by daba y, R as daba 2 f by daba x2, S as daba 2 f upon daba x daba y, T as daba 2 f upon daba y2, then this dy by dx becomes minus P upon Q. Okay, so where P is daba f by daba x, Q is daba f by daba y. So dy by dx becomes minus P by Q. So please note it down. For implicit function f of xy equal to 0, where you can't write y in terms of x, but you can find partial derivative of y with respect to x in terms of partial derivatives. I repeat, if f of xy is implicit function in which you can't express y in terms of x, still you can find derivative of y with respect to x by expressing it in terms of partial derivatives, minus of daba f by daba x upon daba f by daba y, or minus of p by q. So write down.
Sir, I understood how from after the first step we came till p by q minus p by q. But what
Hmm.
about the first step? How did we write dz by dx as that?
This.
Yes, sir.
Okay. So apply definition of total derivative. If f of xy was the function, what was df by dy? Df by what is df? Let us understand that dx or apart later. What is df? Tell me from definition of total derivative. What is df?
First df by dx into dx by right. Okay, I got it, sir.
Yeah,
So,
good, good.
uh,
Can you go to the next slide?
yes, sir.
Yes, sir.
Okay, fine. So with this notation, you can find out second order derivative d2i by dx2, okay, uh, which you can find out by applying quotient rule to this minus p by q. Okay, quotient rule of derivative to this minus p by q, and it turns out to be a determinant. Okay, so d2i by dx2 is minus q into dp by dx minus p into dq by dx upon q square. And if you simplify this further, so d2i by dx2 is equal to 1 by q cube into determinant of rsp, stq and pq0. Okay, so this is important. So please write it down. Second order derivative of y, which is implicit with respect to x, is 1 by q cube into determinant of rsp, stq, pq 0, where rst and pq are defined earlier. Okay.
So could you explain how we got determinant?
You need to find out dp by dx from this. You need to do this calculation dp by dx, dq by dx from this
Okay.
expression. Yeah. So you find out dp by dx and dq by dx. Substitute there. Substitute here. Then you do q square. You keep this aside. Okay. Keep this calculation aside, and then you do this calculation. You find out determinant of this whole thing. These two expressions will be same. Are you getting? Yes or no? Please respond.
Yes, sir.
There would be a difference of that
Yes,
q
sir.
cube as a factor, right?
Yeah. So 1 by q cube is there. I mean, you need to take this q cube to this side, then and only then they will match. Because you can see that there is a q square. Copied?
Oh, sir, 1 minute.
Okay. I want you people to actually check this, okay? Then and only then you will understand. Fine? Can we go ahead now? Please respond.
Yes, sir.
Yes, sir.
No, sir,
Sure.
1 minute.
All right. So just I'll wait for you.
Sir, we don't have to copy the solution below, right?
Don't copy it.
Okay, sir, they're done.
Yeah. Uh, I'll leave this problem to you. If f of xy equal to 0, then and phi of yz equal to 0, then show that this. It is simply uh, uh, finding dy by dx and dz by dy and multiply them, you will get required thing. Okay. So this is not that much important. So I'll leave this to you. Okay, this example. If you can take screenshot if you want. Done? Have you taken screenshot if anyone wants?
Done, sir.
All right. So here are some examples based on implicit function. The function is cos x raised to y equal to sin y raised to x. Then find dy by dx. Okay. So what we know is dy by dx is equal to minus p by q, where p is da by f by da by x and q is da by f by da by y. So from this we need to find out function of xy. Okay. So what we do is let us apply log on both sides. So this is y log of cos x equal to x log of sin y. So f of xy equal to 0 is our implicit function. So you can take this x log sin y to this side, which becomes minus. So y log of cos x minus x log of sin y equal to 0. Okay. So this is your f. This is your implicit function f of xy. So dy by dx is equal to minus p by q. So find out p, that is da by f by da by x. That means derivative of this function with respect to x partially. So y as it is, derivative of log of cos x is 1 by cos x into minus sin x, minus log of sin y as it is, derivative of x is 1. Okay. So if you simplify this, this is minus y tan x minus log sin y. This is da by f by da by x. Then da by f by da by y. So differentiate this with respect to y partially. So log cos x is constant. Derivative of y is 1. So this is log of cos x minus x constant. Derivative of log of sin y is 1 by sin y into cos y. So which becomes log of cos x minus x cot y. Then you simply substitute this da by f by da by x and da by f by da by y, and you are through. Okay. So just note it down, and we'll stop here. Just write down your name and roll number in chat box before you leave this meeting. If you want to copy this, you can write it down and you can leave the meeting. Okay. Or you can ask your doubts if any.
Sir, when will you send the PPT for this?
Once I finish this,
Okay.
You want it right now?
Yeah, I mean before the tutorial for this week.
All right, fine. So I'll send it immediately.
Hello, sir.
Ah, yes.
So in the very beginning, you told us about that there would be some kind of group activity and
Yeah,
activity in a group of two.
right, right, right.
So any update
Uh,
on that?
have you prepared group for other subjects?
Yes, sir. We have groups for
All
DTL
details.
basically.
Okay, and you have started with group activity for that subject?
Yes, sir. DTL is basically everything is group activity,
Yes,
sir. So we have started. There are groups of 4 to 3 students.
so we have already completed our.
Okay, okay. So there are a group of 4 to 5 people, or less
Sir,
than
three
that,
to
or
four people.
3 to 4 people.
Um,
Okay. And how many groups are there total? Total number of groups?
so in our A3 batch, there are 4 groups, I guess. 4 groups, yes.
Okay, A3 4. So that case will be same with A1, A2, A4. Okay. So on Thursday's lecture, let us discuss about group activity.
Yes, sir.
Okay. Fine.
Yes, sir.
So Thursday 9:30. Uh,
Sir, in the last result, it should be negative sign.
uh, so there is already minus sign, no? That minus minus become plus. If you take minus out from this da by f by da by x, that minus minus become plus, isn't it?
Oh yeah, yes, sir, yes, sir. Sir, sir, can you show that that slide, the variable to be treated as constant
Fine,
one?
fine.
Thank you, sir.
Yeah. Okay.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Yes, sir.
This one,
Yes, sir, yes.
you are copying or taking screenshot.
A screenshot.
Okay. Fine.
Yes, sir, done.
Done. Okay.
Yes, sir.
May I stop sharing now? Others?
Thank you,
Will.
sir.
Yeah. Okay.